Differential equations have two types of solution. One is a general and the second is particular. So for my differential equation, x, y prime plus y equals 0, y equals c divided by x is the general solution. Now, if I wanted to say have c equals 1, then my curve right here and right here would be solutions to this differential equation. While if instead I had c is equal to -2, then these curves right here would be solutions. So depending upon our what we're going to call initial conditions, we can have a different particular solution. Now, particular solutions are derived from the initial conditions. And the initial conditions are simply variables of the dependent or one of its derivatives. We use the term initial conditions because in the sciences, a lot of times we're referring to knowing what a particle is doing at an initial time. But the initial conditions can be at any point on the curve. Let's look at this differential equation. S double prime equals minus 32. And I know that one general solution is S of t is minus 16t squared plus c1t plus c2. So this is my general solution, and this is a differential equation. Suppose I give you the initial conditions that s at t equals 0 is 80 and s prime at t equals 0 is 64. How do I find my general solution? Well, the first thing I want you guys to do is, I know I need to get to the second derivative here. So I have s of t is minus 16t squared plus c1t plus c2. So let me first find s prime of t, and that's minus 32t plus c1. And then s double prime, I'm just going to verify, is minus 32. All right, so now I'm going to use my initial conditions to find some of my C1s and C2s. Now if I plug in S of 0 into S of t, that is going to give me one of my constants. So when I plug in S of 0, and I know that that is equal to 80, this is going to be 0 plus 0 plus C2. So C2 in this case is 80. And I've used this initial condition. Now I need to find out what C1 is. Now I have S prime, so let me go to my S prime formula. So S prime of t is minus 32t plus C1. And I know S prime at 0 is equal to 64. And so this is 0 plus C1. So C1 is 64. So now I can write the particular solution of my differential equation is S of t is negative 16 t squared plus 64 t plus 80. Now we want to find the particular solution of x, y prime minus 3y equals 0. And I'm telling you that the general solution is y is c x cubed. And these points right here, y equals 2, x equals negative 3, these are initial conditions. Well, the first thing I need to do is find y prime. So y prime is equal to 3cx squared. Now, I want to verify this is a solution just because this is a good habit. So x times 3cx squared minus 3 times cx cubed. Okay, this is 0, so indeed it is a solution. Now, I want to find the particular solution. So to find it, I'm going to go to my initial conditions. I have x and I have y. So let me go to this general solution here. Y equals c x cubed. So let me plug in y is 2, and this is c, and x is negative 3 cubed. So when I solve this for c, I get 2 divided by negative 27. So for this equation, I get a particular solution of y is equal to minus 2 over 27 x cubed.